Bismillah ar-Rahman ar-Rahim. This is the first tutorial in this course, and in tutorial number 1 we have 3 I think problems. Let us start with the first one. It says that based on the output of harmonic analyzer, it has been determined that non-linear load has a total root mean square current of 75. Also it has, so this is the root mean square current that we have, and also it has third, fifth, seventh, ninth. So we have the third harmonic is given, we have the fifth is given, seventh is given, and ninth is also given. He said determine the fundamental current. So we'll have to find the fundamental current I1. Well, we know that the root mean square of the current will be given by the square root of the fundamental component square plus the third harmonic square plus the fifth square plus seventh square plus ninth square, and that will give us the result because this is given. So we'll take your square both part, then you will be able to calculate I1. Okay, this is part A. Part B, say the amount of third, fifth up to ninth current in percentage of the fundamental. So that means we need to find I1, we need to find the percentage of the third harmonic. So I3 over I1, I5 over I1, and so on. So that will give us the percentage of those harmonic with respect to the fundamental component. Part C, the amount of the total harmonic distortion. Well, you know that total harmonic distortion for the current will be equal to summation of the square of the different harmonic divided by I1. All currents are with us, so then we will be able to find the total harmonic distortion. Maximum through power factor. We know from the unit or chapter number 2 that so there is a proof for the maximum through power factor. So the maximum through power factor will be given by 1 over, so it is 1 over the square root of 1 plus total harmonic distortion for the current square. Then we'll be able to find the maximum through power factor. Part A said if the peak current is 112, determine the crest factor. So crest factor will be equal to I peak over I root mean square. So this one will be the solution. That will be the solution for this problem. Okay. In problem number 2, it says that 4.16 kilovolt 3-phase feeder is supplying a purely resistive load of 5,400 kilowatt. It has been determined that there are 175 of zero sequence third harmonic. Okay, so we have third harmonic of the voltage. We have the harmonic is given as 75. Third harmonic, and we are given also the fifth harmonic. Also we are given fifth 75. If the fundamental voltage equal to V1, so we are given V1 equals to 4.16 kilovolt. Determine the following: the total voltage harmonic distortion. So in part A, total harmonic distortion for the voltage, we apply the equation. We have V3 square plus V5 square divided by V1, so that will give us the total voltage harmonic, and then we have to check it. In part B, we need to check whether it is within the standard. So we have a table of IEEE, and it says that for any voltage below 69 kilovolt, the total harmonic distortion should be less than 5. So then we need just to compare whether it is within the standard or not. So that is for part B. Part C, he said, calculate the root mean square value for the voltage. So we know that V root mean square will consist of the fundamental and the harmonic. So that will give us the root mean square. Okay, part D, he said if the voltage crest factor is 1.05, determine the peak voltage. Well, we know that voltage crest factor is equal to V peak so the voltage crest factor is equal to V peak divided by V root mean square. V root mean square is calculated, V peak is required, and we know this one, then we can calculate V peak. So that times that. And then he said calculate what will be the fundamental current. So find the fundamental current. Well, to find the fundamental current, the power is given. So we have this amount of power, and it is for purely resistive load, and this is the applied voltage. So then we can find the current, right? We can find the current that flows through this resistor. So we know that current, this is for part E, current will be equal to power divided by root 3 times the voltage because cosine is equal to 1 since it is purely resistive load, and this is 3-phase, so that's why we put root 3. So the power is given 5.4. Okay, the power is given, the voltage is given, then we can find the current. So that will be the fundamental current. Calculate the part F, calculate the resistance. So resistance will be equal to, now we know the voltage, of course per phase, so over root 3, we know the current. So we know the voltage per phase, we know the current, so that will give us the resistance. Part G, part G, he said calculate the harmonic current I3 and I5. So then I3 will be equal to V3. Of course, if the voltage that was calculated over here are the line value, so it will be V phase. So I3 will be V3 over root 3 divided by R, and I5 will be V5 over root 3 divided by R. So that will give us the current. Of course, the solution is provided over here. Okay, this is with respect to the second problem, and now we're gonna go to the third problem. Okay, so in the third problem, let's say that the current flowing through a linear RL element. So we have over here R L element, and the value of R is 10 ohm. The value of L is 31.85 millihenry, and the current that flow through them is IT, and it is given by 15 cosine plus 5 cosine 300 by T. Of course, this one will be omega T, right? This is omega, so omega will T is equal to 2 pi times F. Okay, so over here, if this is our omega 1 at the fundamental component, or for the fundamental component, this one will be 3 times. Okay, so the 3 times. That means we have the fundamental component for the current, which is I1. If I write it as magnitude and angle, it will be 15 over root 2 with angle 0. And then we have the third component for the current, or the third harmonic, which is 5 over root 2, also with angle of 0. So both of them are with angle 0. And of course over here, if we look at, so this current will flow over there, it will flow through R and flow through X. Just we need to make sure that when we calculate X, because this is L, X is equal to omega L, okay? So we need to make sure that we are using the proper omega. For the fundamental component, so omega will be 100, but for the third harmonic, the omega will be 300. So this is what we need to take into consideration. Say that calculate the voltage across RL element. So we need to find the equation for the voltage. Well, what we can do, we can find Z1 as magnitude and angle. So this one will be 10 plus J omega L. Okay, and Z3 will be also 10 plus J3 omega L. And then we're going to find those as a magnitude and angle. Magnitude and angle. Okay, so we find I1, I3, Z1, Z3. So now how to find the voltage? V1. So then we're going to find V1, I1 times Z1. So that will be also, it will give us magnitude and angle. We're going to find V3 as I3 times Z3, which will give also magnitude and angle. Then the equation of the voltage, of course we have to write this one as magnitude cosine plus magnitude sine. Same thing over here. magnitude cosine plus magnitude sine, and that will give us the equation of the voltage. Okay, so that will be the equation of the voltage. Part B, so this is with respect to part A. We can go to part B. It said find the total harmonic distortion for the current and for the voltage. So total harmonic distortion for the current will be only total harmonic distortion for the current will be equal to the square root of I3 square divided by I1 only, which is given, and for the voltage same thing will be V3 square over V1. Okay, that will give us the total harmonic distortion for the current and for the voltage. Part C, calculate the real reactive apparent power absorbed by the element. So we need to find P real. Of course, the real power will be only consumed in the resistance. Okay, it will be consumed only in the resistance. So it will be I1. It can be I1 square time R1. So that will be the real power plus I3 square time R1. Okay, so it can be found from I1. Okay, of course this will be the root mean square time I1 square time R plus I3 square time R. So that will give us the real power consumed by the circuit. That is for P. For Q, it can be found also from I1 square time X1, I will call it, which is when omega is equal to 100 plus I3 square time X3, where X3 will be this one, 3 omega L. So that will give us the value of P, that will give us the value of Q. Then S can be found from P root mean square time I root mean square, where of course P root mean square will be the square root of V1 square plus V3 square, and I root mean square will be I1 square plus I3 square. So that will give us S. Okay, part D, find the displacement and through power factor. So we know that the through power factor for part D, so through power factor will be equal to P, which is already calculated, divided by S. So that will be the through power factor, and the displacement power factor will be the angle between V1 and I1. So the angle between V1 and I1, that will give us the displacement power factor, because the definition of the displacement power factor is the angle between the fundamental component of the voltage and the current. Of course, over here you are given the solution as it is shown over here. Well, this is another way. We have the equation of the current that goes through the impedance. So the voltage through the reactance will be equal to LdI by dt. So take derivative of the current, and that will give you the result. So this one will be the final equation for the voltage. Of course, how can we do it over here? As I told you, that convert the current to magnitude and angle, for both harmonic, find Z, find multiply I times Z, that will give you V1, I3 times Z3, that will give you V3. Okay. Or you can use this way. Okay, or you, okay, so as we said that, find Z1, as we did it, so magnitude and angle, find Z3, magnitude and angle, like what we did over here. Okay, then find V as Z1 I1 plus Z3 I3, and that will give you the result. Total harmonic distortion, of course, it will be only the third harmonic divided by the fundamental. Same thing will be the third harmonic for the voltage divided by the fundamental. Now, with regard to power, it can be calculated, as we said, that since real power will be only dissipated in the resistance, so it will be I1 square R1 plus I3 square R. Or, since you find over here, you have the equation of the voltage and you have the equation for the current as well. So we know the equation of the voltage and we know the equation of the current. So we know that the average P average will be equal to VI cosine, the angle between the voltage and the current. So that will give us the result. So VI cosine plus VI cosine, that will give us power, and that and for the reactive power you have to have sine. To find S, as we said, V root mean square, I root mean square, you will find it. For the displacement power factor, it is the angle between the fundamental component of voltage and the current. For the true power factor, it is P over S. And this is the final problem in this tutorial. Okay, so over here it says that we have office building, measurement of a line current of a branch circuit serving exclusively a computer load has been made using harmonic analyzer. The output of the harmonic analyzer are phase current waveform and spectrum of current supplying each electronic power load. The fundamental current was 58. It is absorbed from the spectrum that there is 100% fundamental and the rest are tripling harmonic, and they are only odd tripling harmonic, and they are the third, the 63%, 9th, 4.4%, 15th, 1.9, 21st, 0.6, 27.2, 33rd, also 0.2 order. If it is assumed that loads on three-phase are balanced and all have the same characteristic, determine the following: the total root mean square tripling harmonic current in each phase. So we know that the tripling harmonic current will be equal to the square root of the third harmonic plus 9th plus 15th and 33. So that will give us the tripling harmonic, which are given to us, right? Of course, it can be found as a percentage, or we can find the third harmonic by multiplying 58.5 times 63.3 over 100 and so on. So we can find it as a percentage, or we can find it as ampere. Part B, calculate the root mean square value of the phase current in per unit. So we need to find the root mean square current. So of course we know that the root mean square current will be given as, again, the square root of the fundamental plus third harmonic plus until the 33. So that will give us the root mean square current. And if it is in bare unit, so this one will be one will be 1%, will be 100%. I1 will be 100% because to the fundamental component it has 100%. So that will give us the root mean square. Then he said in part C, calculate the approximate root mean square value of the neutral current in bare unit. Of course, we know that since we have only tripling harmonic, so all this tripling harmonic will go through the neutral. Then I neutral will be 3 times the I tripling harmonic. Right? So that will be the neutral current. The ratio of the neutral current to the root mean square current. So I guess we need to divide what we obtain by I root mean square. Then find the total harmonic distortion. So we know that it will be the I3 again, I3 square plus I9 square plus I15 square plus divided by the fundamental component. So that will be the total harmonic distortion, and the solution of course is provided over here. So this one is found as a percent. Then to find the root mean square, so this one is taken as 1 per unit, or it can be found as in percent. I neutral will be 3 times the tripling harmonic. This is the relationship, and then you will find the total harmonic distortion. Thank you, that's all.